Hey everybody, it's Al with BobCAD. So I wanted to talk about some 3D boundaries and options and control. This is the kind of stuff that, you know, when you're machining parts in 3D and you want to isolate different areas and really have more control over where your tool is cutting and where your tool isn't cutting. And in BobCAD, we have lots of different options for this. Some options are much easier to handle than other options, and you know, in this example, or it may be your budget, you know, depending on what level of the software you have available. So what I want to do here is, the first thing I want to look at is the ideal scenario. So you have this this surface you want to machine here, okay, and it's in orange. And you only want to machine that surface. And so what is the methodology that you have? So if we come into our multi-axis routines, you have a bunch of different surface-based strategies, and one of them that's really popular is morph between two curves, and that's the one I'm going to use in this example very quickly. I'm going to set the ball mill that I'm going to use. I'm going to pick my first curve, which would be this top edge here. I'm going to pick my second curve, which would be this bottom edge here, and then I'm going to pick my drive surface, which is this surface here. Okay. From here, I can say 3-axis cutting, and I can compute my tool path. And at first, you know, you can see that it's cutting on the wrong side, so I want to adjust that. You may ask, you know, why is it cutting on that side? Well, that has to do with the surface normals, and when you're in multi-axis, you have to pay attention to that. I'll click on surface normal here, and these little arrow lines, that is which way the surface is pointing or which side the tool path would be generated on. In this case, I need to reverse the surface normal here. So now you can see that normal is sticking out. I can reselect my surface here, and then I can go ahead and compute this. And now you can see the tool path is being generated right in that area. Now, with that said, you know, I really want to make sure that it doesn't touch this top surface and it doesn't touch these surfaces on this side. So within multi-axis, you have what's called check surfaces. So we can go to gouge check, and we have our check surfaces here, and you have a couple of different options as far as what happens when a collision occurs. We're going to just say retract tool, and then for our check surfaces, we're going to go ahead and select this top one and this front face here, this curve here, that curve there, spacebar, recompute, and you know, now what we've done is we've made sure that the tool path, the tool isn't going to cut along any of those other surfaces besides this one here. So now that's great, but you may not be a multi-axis customer. So if you're not a multi-axis customer, what are your options, and how can you handle a scenario like this? Now, in the first example, what I have is what you would typically use, which would be a Z-level finish with a boundary, and we can control the levels. But you know, running it this way, this if we look at it from this angle, this surface kind of dips down, and you know, so if we're cutting, we could control our levels, but we still may be cutting along this surface here, and we don't really want that to happen. So what do? Well, we got to edit our surfaces, and there's a couple of different ways to do that. Now, right now, the 0 for the part, if I turn on my axis, the 0 for the part is on the bottom of the part. So what I want to do is I want to create a plane on the top of the part. So I'll go to my UCS, add new UCS, planar face, and I'll pick this surface up here. Okay, so now I have a plane for the top of the part. The next thing that I want to do is I want to extend this surface. So before I can extend the surface, I need to untrim it. So I go to surfaces, I go to untrim surface, and I click on this surface here. So that's now untrim the surface. The next thing I need to do is I need to extend this. So I'm going to go to surface, extend, and we'll say 2 mil, and we'll do 2 mil on this side here, spacebar, 2 mil on this side here, spacebar, and 2 mil on the bottom here. Okay, so now I've extended the surface out. Now that I've extended the surface out, I really want to cut the top of it so that it doesn't extend past the top of the part. So I'll just sketch a rectangle here like this. Okay, so now I have a rectangle sketched. Let me change the plane color. Let's make this to a gray. Okay, so now I'll generate a surface where that rectangle is. From there, I'm gonna add those together, so we'll add this and this together. Okay, from there I'll unstitch solid to surfaces. That will break it down to the surfaces, and then I can get rid of the top part and I can get rid of the bottom part, and then now I have just this extended surface here that I can use when I select my geometry. Now the last thing I need to do is I need to measure from the top of the part to the bottom of this edge here, so I know how deep to tell it to go. So I'll create another layer, utilities, extract edges single. Let's pick this this edge here. From there, I'm going to do point on entity 50%. It's not an easy spot. Let me see if I can turn off some of these layers. Okay, so now we can see that curve. Point on entity 50%, and then what we want to do is we want to measure this so we can see how deep it is. And from that plane down, this is minus 1.89. So we have pretty much everything we need at this point. I can go back to a top view. I can turn my surface back on. I can do my Z level here. So we want to select all this stuff. So remove, reselect, select all, spacebar. So now we have all this geometry selected. We can remove our boundary and recompute our toolpath. Okay, so now we see that it's going all the way around, but we see it's picking up this new surface that we've added here. We want to adjust our levels, so we'll come in to parameter bottom of job is going to be minus 1.9, let's say. We'll recompute that, so now we can see it's only going down. It's only going down to that depth, and the last thing we want to do is we want to give it a boundary, so we want to control where it's cutting in so that it's not going all the way around the part. So let's blank this out. I'm just going to add a new layer here, and I'm going to do utilities, extract edges single, and we'll pick on this top curve here, and we'll click on that edge there, and click on this edge here. I'm going to just turn everything else off. From here, I'm going to do utilities, translate. We'll make this Y 3 millimeters. We'll grab this one, grab that one. We'll click OK, and then we'll just do line join. Now, one of the things that you may not realize is that your boundaries in BobCAD do not need to be flat in the XY plane. So if we look at this, well, that happens to be flat, but it doesn't have to be flat. It could be curved in 3D. Let's go ahead and select our boundary here, and then we will recompute our toolpath. And now we can see the toolpath is staying within that boundary, cutting down, following that surface. So there's always more than one way in which you can cut this type of geometry, and sometimes just expanding your surfaces or extending your surfaces will make things a lot easier for you. So hopefully that was helpful for you. If you have any questions or comments, you can reply back on the Facebook, the YouTube, or whatever thread this video may be posted in. Thank you so much, guys.